Ta-dam! So, hey guys, my name is Viktor Isaev. I'm an enterprise architect here at DevExperts. And today I'm gonna talk about building apps in serverless AWS cloud. So if you're thinking whether you can run an application in AWS, pay less than $1 per month while still having 24/7 availability and high resiliency, I would tell you that you certainly can by using serverless, right? And in today's 25 or 30 minutes speech, we'll see how it is. First of all, a little bit about myself. As Katie said, I have more than 20 years of hands-on experience in software development. I was in multiple companies, started as a developer of back-end applications. And also I have more than 5 years of experience in developing software architecture as a technical lead, as a team lead, and finally as an actual architect, right? And also I am an officially certified AWS Solutions Architect Associate. So more or less I know what I'm talking about. Our agenda for today, first of all, we're gonna define serverless, and we're gonna understand what is that. We're gonna see the why of using serverless, so the motivation part. We're gonna see how serverless compute works, and also we're gonna see if we can have a serverless database. We're gonna look at a real example of a serverless application inside our company, a small experimental Slack bot, which is completely serverless. And also we're gonna touch the high load topic, whether you can handle high load with serverless. I guess hopefully we'll be in time. So first things first, what is serverless? It's very easy. So serverless is running your workload or application without any dedicated server or servers. So you just have some code, some business logic, you run it, kind of invoke it, it runs somewhere, gives you the result, and that's it. And you don't care about the real infrastructure, you do not provision any servers or virtual machines, nothing of that. It just works somewhere. And this somewhere is actually a pool of resources exactly for the purpose of running your serverless workload. So in this example, there is some business logic code called Lambda function, and it runs on one of the machines inside hidden pool in AWS, and the virtual machine is picked somewhat at random, and your several invocations of this function may run on different machines from that pool, but you don't manage it. So it's managed by AWS, you cannot even touch it. That's serverless. Okay, sounds good, right? So let's actually understand why is that needed. So it sounds a little bit kind of strange or complex. And to understand the why of things, we're gonna travel back in time a little bit in the era when there were actually no virtual machines. Well, actually there were virtual machines, but they were not widely adopted, and guys were running their applications on the physical servers. I guess it's early 90s. So there is already internet, there's already servers, but not that everybody uses virtual machines all over the place. And in case you have a bare metal physical server and you run your application on a physical server, typically a physical server has much more resources than your application actually needs. So your application, a typical one, some backend service for handling your HTTP load, actually requires some kind of 2 gigabytes, 3 gigabytes of RAM and a couple of CPUs, right? While a physical server has much more than that. It has 20, 30, 40, 50 at that time, 60 gigabytes of RAM, 16, 32, 64 CPUs, and you have much more resources than you actually need for your single application, and your resources on the physical server remain highly underutilized. And you can, of course, run multiple applications on that same physical server, but in this case, they are not isolated. And the failure of one application may cause failure of other applications. For example, if there is a memory leak and it consumes all the memory, all the rest of the applications stop working in that case. And also, you typically over-provision your physical servers. If you are a real e-commerce, let's say, company, you may have some rare but very important events like Black Friday, where your traffic can spike 10x, 20x, 30x, and you want to handle all that traffic. You want to handle all these crazy requests for purchasing stuff and kind of financial transactions, and you want to have spare servers in that case so that you can handle this 30x traffic. And most of the time, these spare servers remain just simply unused, right? And then came the virtual machines. So the idea of the virtualization is simply to slice your physical servers into a bigger amount of virtual servers. So each virtual machine is kind of physical server, but with less CPU, less memory, designed exactly for running a single application. And this way we have this isolation between the applications, and if one application fails, all the rest of your workloads remain untouched, because every application thinks that it runs on the physical server, and it's just like it runs on a single physical server. And also, you may place multiple virtual machines on your physical machine and utilize resources much better. But still, the available resources are more than you need. Also, if you are running your virtual machine in the cloud, let's say AWS, you typically pay for the time you are using this virtual machine. So you go to EC2 console, you order the virtual machine, you launch it, and at that exact moment you start paying money for that. You're not yet running your workload there, and your workload might receive 1 or 2 or 3 requests per day, but you are still paying for the whole day of using virtual machine, and this happens every day. So still, there are much more resources than you need, and you pay much more than you're probably willing to pay, right? And here comes the serverless. So in serverless model, you only pay for the execution time of your business logic and your function. And if you have 1 or 2 or 3 requests per day, you're going to pay just for the time these requests are executed, and you're going to pay nothing all the rest of the time. And this is a great cost-saving option, because if you have some kind of a small experimental application, you don't know yet whether you will receive high traffic, it's very optimal, not very optimal, it's wrong to say that. It's kind of very fortunate in terms of billing to use serverless for this application, because you're going to pay much less. And so, and same goes for storage. And so serverless model is a kind of pay-as-you-go model for pricing, and it's a great cost-saving option, as I said. So here is a quote from Jack Van Lightly's blog. It's a great blog. Jack Van Lightly is an architect, And he says the following in his series about the serverless databases, actually. So large-scale multi-tenant systems, which is AWS Lambda for serverless, increase resource utilization, as I said, right, via resource pooling, which drives down operating costs significantly. I told you about the operating costs, which go down, but a couple of words about resource pooling. So when you are using serverless, you typically run in a multi-tenant environment where your code runs together with code of other customers and other accounts. And by using this kind of joint pool of resources, this helps further reduce the actual cost of using this huge resource pool. So multi-tenancy helps reducing costs. It's the whole philosophy of AWS, where you have a single huge resource pool, multiple customers, and together kind of we pay less. And in serverless, it's just paying less on steroids. So paying minimal cost for the resources you actually need. So how does the serverless compute works? Now that we have spoken about what is serverless and why using serverless. So serverless compute in AWS is called AWS Lambda. And in Lambda, you can write your code as a so-called Lambda function. You can use Java, you can use Python, you can use Golang and JavaScript, and I guess there are some more languages to use. And this code can be run inside a special EC2 pool that is called Lambda worker pool. And when your Lambda function gets invoked, AWS dynamically picks an EC2 virtual machine from inside the Lambda worker pool and initializes a special execution environment in there. So it's an environment that has all the necessary binaries and libraries so that your code can run. In case of Python, let's say, there will be a Python executable together with all the libraries you need and things like that. So this execution environment gets initialized and it's completely isolated from everything else that is there on this virtual machine. And there might be multiple execution environments there from other customers. You cannot intersect with that, and AWS guarantees that your environment is isolated. And your code runs there. And this execution environment has access to the resources in your AWS account. You just have to configure the permissions for AWS Lambda to use your resources. And if it's configured the proper way, your code runs. It can access your database or your message queue or whatever you have inside your account. And it works just as if you are running your code inside an EC2 virtual machine. The difference is that this execution environment will be destroyed sometime after your code finishes execution. But it may stay alive if you have a series of requests, and this execution environment may be reused. So if you have incoming requests coming one after another, probably it will be the same execution environment that executes your code to handle these requests, right? Sorry, it's too early. And what's the reason for invoking the Lambda function? What's the trigger to run it? The most popular ones are three of them. The first one is receiving an incoming HTTP request. Typically, you configure an API gateway that receives that and then transfers the execution to Lambda function, passing all the information that came with the request. It's the nice way to handle HTTP traffic. The other reason for calling Lambda function is handling an event from an event queue. So you can handle events in your Kafka message stream by using Lambda function. And the third reason is just a schedule. So you can run your code on schedule and execute it periodically. This is a good thing for running some background processing that is makes some important stuff for your service. Can a database be serverless? Yes, it can. Here is the architecture of Amazon DynamoDB serverless database. I wouldn't be an architect if I wouldn't show you a picture like this. And let's now examine each of the blocks one by one. I'm just kidding. Let's do actually the opposite thing. Let's look at it from the bird's eye view. And when we are looking from above, what do we see here? So first thing that comes to us is that the compute layer and the storage layer are completely separated. So there are separate nodes for running compute, which is handling queries, handling transactions, things like that. And there is a separate pool of nodes for running storage layer, which is the nodes that store your information, retrieve your information from the physical drives, handling the requests for data. And the second thing is that there is no single point of failure here. So everything is scaled out. For each of the parts of the system, there is a massive pool of nodes that handle the proper loads, whether it is the request for reading data or is the request for writing the data. And also, your data is again stored on the storage nodes in a multi-tenancy mode together with other customers' data. But again, it is guaranteed to be completely isolated from other customers' data. You have separate encryption keys and things like that. And also, when you store data in DynamoDB, it's replicated 6 times across the cluster. So you have a high resiliency, and also you have low latency, because these 6 replicas of data can be used to minimize the latency when you retrieve the data. And what's more important here, when we speak about the price and the cost of using this DynamoDB database, in DynamoDB you only pay for the data that you actually store. So if you are if you want to store 1 megabyte of data in DynamoDB, you're going to pay for just 1 megabyte. Probably it will be $0 per month. Next one. Yeah, a real example. So inside DevExperts, we have built a small experimental chatbot for Slack, which responds to the questions about DevExperts. It's made for internal customers, our colleagues, and it uses our wiki as a knowledge base, and it uses ChatGPT as an AI engine, right? And this experimental small application is completely serverless, and we actually pay less than $1 per month for the whole infrastructure of this application architecture. So first of all, there is Slack, and there is a bot application inside Slack, which is just a configuration record. So we tell Slack, hey, there is our application. Here is the endpoint you should go to. Please show it to colleagues inside our Slack workspace. Next, inside AWS, it's our AWS account, and we have an API gateway that receives HTTP requests from Slack, right? And API gateway is a completely serverless service, which is fully managed by AWS. So we have no actual infrastructure there, just the configuration rules that tell which endpoints do we have. And inside API gateway, there is a configuration rule that tells the gateway to transfer handling of the request to the Lambda function, which is a single function. for handling bots business logic. It's written in Python, and it gets deployed from Docker image that we store inside ECR, which is Elastic Container Registry. It's just a Docker registry inside AWS. The bot function stores its data inside DynamoDB. The data is by nature very much key value. So when you receive a message, you have user ID, you have message ID, and everything can be retrieved by ID. So it's very fortunate for us that we can use DynamoDB, because DynamoDB is a key value storage, right? And it's quite natural to use it for storing data. And again, we don't have much data, and so we don't pay much for it. Of course, there is monitoring, and there is a CloudWatch service in AWS that helps us monitor the execution of this bot function. We can have graphs where we have kind of number of requests per day and things like that. Well, also we have logs, and if there are some errors in the log, we can trigger the alarms and receive emails and things like that. And also, the function can access services outside of AWS, which is OpenAI's ChatGPT. It uses the REST API for interacting with ChatGPT assistant. And this is the way how we answer the question. So the request comes in, we look at the request, we transfer it to ChatGPT, also using some information from inside our wiki for the context, and then we receive the response and give it back through the API gateway to the Slack bot application, and it displays it in Slack for the employee who asked the question. Completely serverless, very cheap, and working 24/7. So we have spoken about how serverless compute works, what is the serverless database and how it looks like. Also, we have examined a real example of a serverless application. But what if you have high loads? And if your application is serverless, can it handle high load? So the answer is yes, it can, but you should keep certain things in mind. If we're speaking about serverless compute, there is a embedded initial limitation, a quota for every account by default for 1,000 concurrent requests at a time. So if you receive 5,000 simultaneous requests, first of all, my congratulations. And secondly, you need to provision the quota to be able to handle that. It's just, you just need to inform AWS that you are going to receive high traffic, please raise me the quota. That's it. It's not worth anything. You won't pay for that. Just a matter of configuration. It's the thing number one. Thing number two, if you have a steady load of 1,000 requests per second, and your traffic suddenly spikes and starts like kind of 3,000, 4,000 requests per second, Lambda needs some time to initialize additional execution environments. And this is the added latency. And you should keep that in mind. It's typically, probably it's going to be less than a second, but probably is a keyword. It might take longer. And if you don't want to avoid this latency by any means, if you have kind of a low latency application and you want it to always immediately start handling the requests, you need to provision for that. And provision means pay money for upfront initialization of these execution environments. So you can say, you can tell AWS, hey, let me have 1,000 execution environments in advance, and you're gonna pay for them in advance. It's not really how I would try to operate. I would try to avoid doing that by any means. but still there is that option. For DynamoDB, actually it's more or less a similar thing. So there are two modes for running a DynamoDB database. First is on-demand scaling, where you scale the database as you go in terms of handling traffic. By default, just as a starter, it is capable of handling 4,000 write requests per second and 12,000 read requests per second. But if that is not enough and you have higher traffic, it is able to immediately scale twice as much, but not more. And if you have higher traffic, the requests would be throttled until 30 minutes pass. So there is this kind of stairs when you grow your traffic. And if you want to avoid your requests to be throttled, again, you need to provision in advance, which means pay some money in advance to be able to handle high traffic. So this automatic scaling and is just a matter of time, and if you don't want to spend any time, you need to pay in advance. That's the trade-off. And hopefully I explained this well, and hopefully we are in time. And given that said, actually let's wrap up. So we have seen that serverless is a great cost-saving option, pay-as-you-go model with maximized pay-as-you-go. We have seen what is serverless compute and how it works. It's AWS Lambda. We have seen a serverless database, which is AWS DynamoDB. And we have seen the typical architecture of a serverless application, and even we have touched the topic of high load a little bit. And so that's actually the end of my talk, I guess, and I welcome your questions.